Welcome in the fourth section of Building Big Data Stack course, and in this section we'll be learning about machine learning toolkit that is available in Apache Spark. We'll be using Spark MLlib, we will build an anomaly detector, we'll be composing Spark ML stages into multiple machine learning pipelines, and at the end we'll be using collaborative filtering to create a recommendation engine. And in this video we'll be composing Spark machine learning pipelines. So we'll be learning Spark MLlib API, we'll be creating an anomaly detector, and we'll be composing machine learning stages into a pipeline. So we have an input of HTTP requests. So this is a file of millions of HTTP requests. So this is an ID of HTTP request, then protocol that is used, bytes that were sent, bytes that were received, and so on. And in that file there will be some anomalies. So if we have some kind of attacker that wants to hack our website, that file will show that. So we want to find out which of those requests is an anomaly, and we will build an anomaly detector that will find out which of those requests is an anomaly. We'll be using k-means clustering that will cluster those requests into clusters that are separate from each other, and if the request that arrived to our program is not within any of known clusters, we will treat it as an anomaly. So this is our Spark job, and we'll be using MLlib library. But to start Spark job, we need to Spark session builder master local, because we want to run it against local environment. Then we need to load our data. So we want to infer schema from CSV file. The header is not present, so the header property is set to false. Then we need to pass a path to CSV file, and at the end we are converting it to data frame, passing names of columns here. So first the duration, protocol time, service flag, and so on. And we can use every of those columns to perform clustering. Then we can run a k-means algorithm using Spark. So let's look at this method. The logic is in the build anomaly detector. So firstly we are defining how many clusters we want in our k-means clustering algorithm. We want to have 180 clusters. Then we have a build machine learning pipeline. That is the most important method to us, because here we will build a machine learning pipeline composed from multiple machine learning stages. So firstly we have a protocol type column that has some values that are not binary, but we need to index it somehow. So we have a method transform column to vector of features. That method is taking a string indexer, because values inside of that column are strings, and one hot encoder that will present those values as a vector of this. And we are creating new pipeline and passing two stages: indexer that will index that values as a strings, and then encode it as a vector of bits. And we are doing exactly the same thing with the service column and flag column, and then we will be able to use those flags but when creating clusters. Then we need to take all columns with feature columns, replace it with vectors. So we are taking all columns that are inside of data frame in Spark. We doesn't take the label, protocol type, service, and flagged columns, because we want to take those feature vectors of those columns, and we are adding these values here. Then we are creating assembler that will assemble all values inside of one big vector that will be passed to k-means method. Next we want to scale our feature vector and scale feature vector, because we want to have it more accurate. And we have multiple stages. At the end we are ready to create a k-means algorithm. We are setting some seed that is a random, we are setting number of clusters, so set k, then we are setting the prediction column name, so the prediction will be inside of the column called cluster. So when we pass a data frame to that k-means algorithm, in the resulting data frame we'll have new column that is a cluster, so it will be a number of cluster to which that specific record was assigned. Then we have a feature vector that will be used to find the clusters, and we are passing a scaled feature vector column. Then we are iterating 40 times and we are finished. At the end, we need to compose those stages into one machine learning pipeline. So we need to create new pipeline and set stages here. So firstly, we are passing 3 encoders that we created. So we are encoding those 3 columns to vector of bits. Then we are passing assembler that is assembling all values into one vector, scalar to make our results more accurate, and k-means that it finally will create a clusters. So here we created an clusters in our model. So let's get back to build anomaly detector method. So we have a pipeline model that is created. Then we need to take k-means model that is a last stage in our pipeline, and we'll be using that k-means model to perform anomaly detection. We want to take a centers of clusters from k-means model that will be a centroids, and at the end we are transforming our input data to clustered input. So we will have that new column that is cluster number, because we will use a k-means to find out that cluster. And the most important thing is to get distance of 2 clusters that are most away from each other, from and top clusters. And that method will find out which 2 clusters has the highest distance between the 2 of them. So this will be a farthest distance, and if the new value that arrived to our program will be longer than this distance, it means that will be an anomaly. So we will have a double that is the highest distance between those 2. And the most important method that will actually find anomalies is the find anomalies method. And we are passing centroids here, clustered, that is clustered input, also the farthest distance between 2 normal clusters, and original columns. So let's look at the find anomalies method. So for clustered data frame, we are filtering, so we are taking a cluster and scaled feature vector and calculating if square distance between any of centroid of cluster and vector is higher than farthest distance between 2 normal clusters. And then we are selecting it. And if something is here, it means that this is an anomaly. And we are showing only top 10 anomalies inside of that input HTTP requests file that we saw at the beginning of this video. So let's start our anomaly detector. And we can see the results. We can see that there is 10 top requests that were treated as an anomaly. So we have some request that has duration of 0 seconds, was TCP protocol, service HTTP, flag, bytes and received, and so on. So then we find out anomalies and we can analyze those requests more in depth.